Finally, let's take a look at an example that wants us to find the distance between a given point in a three-dimensional coordinate system and a given plane, either the xy plane, the xz plane, or the yz plane, the three possible planes made up by our axes involved in this problem. So here, if we want to find the distance between this point and the xy plane, if we want to go directly to that flat surface known as the xy plane, the x and y coordinates of that point are going to remain exactly the same. So we'll have 5 and 3 still. And if you're in the xy plane, there is no z coordinate. In other words, the z coordinate will be 0 with that. Going ahead and setting this up now to solve with our distance formula, we have d equals the square root of, I would have 5 minus 5 squared with the x's, I would have 3 minus 3 squared for the y's, and I would have 1 minus 0 squared for the z's. Simplifying a bit, this would give me 0 squared plus 0 squared plus 1 squared, which would be the square root of 0 plus 0 plus 1, which is the square root of 1, which in this case is just equal to 1 for that. So, long story short, if you're given a point in a three-dimensional coordinate system and you want to know the distance between a given plane, such as the xy plane, ignore the x and y coordinate, and the distance will be the z coordinate. If I wanted to know the distance between this point and the xz plane, I would ignore the x and z, and the distance would be the y coordinate. It's pretty cool. You get a lot of stuff that cancels out and becomes 0. If you try to use the formula, you can definitely shortcut this a little bit.